here first. We'll be recording and distributing this webinar later today. If you have any questions during the webinar, please make sure to ask them in the questions section of the GoToWebinar panel, and we'll answer these at the end. Here's our agenda for today. I'll do a quick overview of Rescale's platform and the AVL Rescale Partnership. I'll then pass this over to David, who will give an overview of AVL and the model we'll be looking at today. Finally, we'll be passing this back to Molyanto, who will be doing a demonstration showing how to run an AVL Fire model on the Rescale platform using AVL Fire on-demand licensing. We'll finish with some time for questions. Rescale provides a comprehensive cloud platform for running simulations. This platform allows engineers and scientists to set up and execute different types of simulations using a straightforward, easy-to-use interface. Rescale partners with multiple infrastructure providers with over 30 data centers globally, allowing our users to leverage a wide range of different types of hardware, including InfiniBand and GPUs. Users can not only run these simulations on the platform, they can monitor their progress in real time using our live tailing feature, and our administration portal allows IT and management to manage and monitor usage and set additional controls. The platform can also integrate with existing on-premise resources, so IT and management can have transparency and control over all resources being utilized through one unified environment. At Rescale, security is our top priority. We go to great lengths to ensure that the platform is secure and that users' information is protected at every step. We go through lengthy and in-depth processes to meet strict security compliance and regulation requirements. Users' data is encrypted both in transit and at rest. When simulations are running, they're being run on isolated encrypted clusters. We're happy to talk further offline and address any specific questions about different security measures that we have in place. So the Rescale and AVL partnership. We have a strong strategic relationship with AVL. This partnership enables AVL users to both purchase on-demand AVL licenses directly on the platform, as you'll see during the demonstration, as well as allows users with AVL licenses locally that just need additional compute power to run on the platform. As mentioned, Rescale's platform is available globally, and in addition to this worldwide range of data centers, we also have dedicated regional platforms in both Europe and Japan for users that require their data runs and is stored in one region. We also want to note that in addition to AVL Fire, through our partnership with AVL, we also support AVL Excite with a bring your own license setup. We'll be having a webinar 2 weeks from today at the same time to go through AVL Excite and how users can run their licenses on Rescale. I'm now going to be passing this over to David at AVL. So David, I will be making you presenter now.
Okay. Okay, is the video okay?
You don't see your screen quite yet.
I shared my presentation.
Do you see the screen? Let me see. No, we can't see your screen yet. It's still the webinar screen.
Mm-hmm.
You clicked the accept?
I'm sharing the entire screen.
There we go.
Is it okay now?
Yep, you're good.
Okay, so welcome also from my side. My name is David Greif. I'm the product manager at AVL for the 3D CFD program AVL Fire with a focus on the multi-phase applications. However, today I will give you an introduction to the diesel combustion system development with AVL Fire, as this application was used as an example of porting AVL Fire to the cloud platform of Rescale. A couple of words about the company AVL, for those of you that may not be from the engine development business specifically. AVL is a global company of about 8,200 people at the moment, developing powertrain systems and measurement equipment. It consists of three main divisions. AVL Powertrain Engineering, as the name suggests, offering powertrain development services. Another large part of the company is instrumentation and test systems, developing test beds, dynos, sensors, all kinds of measurement equipment for the automotive industry. And then finally, we have advanced simulation technologies, where I belong to. And we have four main products: AVL Cruise and AVL Boost for system simulations, 3D multi-body dynamics, AVL Excite, as mentioned before. There will be a special webinar for that in a couple of weeks. And then finally, AVL Fire, which is our 3D CFD tool. The core business of AVL is development of powertrains, measurement equipment, and simulation tools. And simulations are gaining on importance in order to support the development process and enable the front loading. By that, we mean shifting the development tasks more towards the virtual environment rather than having to build many physical prototypes early in the development process. When we speak about combustion system development, regardless if gasoline or diesel, we need to perform numerous simulation loops to meet multiple objectives with potentially conflicting targets. So we are facing very strict legal requirements, as we know, regarding engine and tailpipe out emissions, and those coexist with the general desire for performance and efficiency expected by the customers, and the reliability and durability expected or required by the OEMs themselves. So the solution that we're offering is investigation of large number of designs, variants in virtual environment, and we support 3D simulation activities with AVL Fire in very different areas, not only combustion, there's also other areas that we're looking at. The example that has been chosen today relates to diesel engine combustion system development, and I will just show a couple of examples to illustrate the need for extended computational resources, which could be, of course, provided or are provided by Rescale in this case. And what we have here is the development of the intake port design. This is the part of the combustion system which provides air into the cylinder to prepare combustible mixture of air and fuel, and we perform large computational studies in order to achieve this target. And we can go forward and perform conventional series of computations, or we can perform automated design optimizations. In either case, numerous simulations are needed, and computational resources are very critical. We, of course, can vary engine parameters, operating parameters, as well as geometrical parameters. In either case, we end up with numerous operating points which need to be investigated. What we see here is a number of cases. We are comparing measured to computational results, focusing on the red line here in the middle, falling right between the two measurement techniques, achieving very good agreement between the computational results and measurements for different valve lifts. When we talk about intake port design, of course, we're looking at different valve lifts, different shapes of the inlet channels. And what we have here on the left-hand side for this example are the measured velocity magnitudes at two different locations. This is the measurement on the right-hand side at the planes shown here on the animation here. One is close to the gasket, one is further down. And for two different turbulence models that are available in fire, we got excellent agreement between the measured velocity magnitudes and the computationally predicted ones. So when we move further into the combustion system, into the combustion chamber, one of the geometrical parameters that we vary is the piston bowl shape, and varying the shape of that strongly influences the combustion process, and we would like to optimize the shape to meet all the requirements. So what we're doing here is automatic variation of geometry as well as non-geometrical parameters that go with it to come up with a proof of concept with initial match of performance targets and to make sure that the design is robust. We're facing a large number of designs which need to be performed in very short time, and we want to correlate design and performance parameters. And the effort clearly is related to the computing power that we have available. The approach is such that manpower is only required to set up the optimization loops, and then the simulations themselves run on the hardware or in the cloud as the platform offered by Rescale. An example here shows different combinations of operating parameters. So this is a typical scenario for different nozzles. So we have three different spray angles. By spray angle, we mean the angle between the spray holes on the tip of the injector. We can vary the number of holes. So for each configuration, you have 6, 7, or 8 holes. And we have different swirl numbers, which is the intensity of the swirling motion, the mixing motion inside the cylinder. So we have 0.5, green, orange 1.2, and red, the swirl number of 1.5. Nevertheless, we need to look at the soot formation and the NOx formation. It's always a trade-off between the two, and we need to pick the combination of the engine parameters which meets the current development criteria. This is just for an illustration that the topic is complex. We're dealing with a matrix of cases that need to be calculated, investigated, and then the design is chosen. The animations here are going to show an example of transient soot and NOx formation, soot on the left, NOx on the right-hand side. You will see what happens for different fuel temperatures, 300, 350, and 400 Kelvin on both sides. And what is interesting is I mentioned the trade-off between soot and NOx formation. You will see, for instance, for the high temperature, we have the lowest soot formation of the three, but at the same time we have high NOx formation. So this is an example of the conflicting objectives which need to be then considered in combination with other engine parameters. To wrap up this illustration about the problem that we used for illustrating the porting capability of AVL Fire to the Rescale platform, we're looking at cost and time efficient development targets This is very important in the engineering environment. AVL Fire is a reliable and extensively validated simulation tool containing models for spray and combustion, as well as injection nozzle interface for spray initialization. In terms of hardware, of course, local hardware is the easiest and the fastest option. However, it could be very expensive if not constantly utilized. Therefore, the cloud, like Rescale's, offers an on-demand solution which covers simulation peaks very effectively. The example that has been used is a full single-cylinder model automatically generated in the preprocessor of AVL Fire. And due to its transient nature, of course, problem's transient nature, we have a varying number of cells between 600,000 and 3.3 million, including 79 rezones. And a couple of details, we use, of course, turbulent and compressible flow, Lagrangian spray for mixture formation, ECFM three-zone model was used for combustion modeling, and of course the emissions model has been activated. This concludes my introduction about the problem which was used for running AVL Fire. Illustration on a Rescale platform. I would now hand over to Mulyanto to speak a little bit about how this is done.
Hi, thank you, David. So I will be walking you guys through how to actually run the model that David just showed you on Rescale. And the main goal is to illustrate the ease of setting up these kinds of models on Rescale and the features that make Rescale a good tool for running these simulations. So this is a login page. Here you would have to enter your credentials to log into the Rescale platform. We support both single sign-on as well as multi-factor authentication. This can be set by your company administrator, or you can just set it on your own user account as well. So I'm just going to log in. So when you first log in, you are presented with the job list page that you see here. This gives you a list of all the jobs you have run and you are running right now. It also shows you jobs that may have been shared with you by your colleagues. So in this case, I've got 6 jobs here. And I've got one running job that I started earlier this morning. And another thing you can do on this page is organize your jobs. So there's folders that you can create, and you can move your jobs into the different folders. So to start setting up your job, what you'll have to do is go to New Job here at the top left. And this will bring you to the job setup page. So the first thing we'll do is give the job a name, and we'll call it just AVL Fire example job, for example. And the first step that we want to take is to upload our input files. So we can either upload them from our computer, or we can select them from already uploaded list of files that are already on Rescale. So to illustrate the first file selection, I'll go upload it from my computer. And I've got my diesel engine.zip file, and this is just the case files in this case. And then while it's uploading, in the top you'll see the upload status, and then once uploaded it'll show up here in the list. And the second way of selecting your files is to select them from lists of already uploaded files, and you use this use files from cloud storage option. And I'm going to use this to select my mesh files, which I uploaded previously. So I'm going to add these files. And so these are all the files that I need to start running my AVL fire job. So the next step would be to select my software. You can either select it here at the top in the flowchart, or go to the software setting here on the right side. So when we click on the software settings tab, I'm presented with a list of software. Today we're interested in running AVL Fire, so I can filter the software by adding or typing the name of the software in the top, and then clicking on it, I can select AVL Fire. I can select any of the versions available in Rescale from this drop-down menu. And today I'll be running on our Ivory core type, which is an InfiniBand core type. So we'll select that version. And in the box below it, I have to enter the command to run AVL Fire. Most of the command is already filled out for you. In this case, we only need to replace this case placeholder with the name of the case that we want to run. And in this case, we're running a single case. If you have a multi-case file, you can either run them in serial by specifying multiple commands here, or you could select our design of experiments framework to run multiple cases in parallel. The last thing that we have to set up on the software selection settings page is our licenses. AVL Fire is available for on-demand licensing, so I'm going to select Purchase License, and it will show you the table of rates for purchasing AVL Fire on demand. So the next step is to select our hardware, and again you can select go to the hardware settings by selecting it in the flowchart at the top or on the right side. And here you'll be presented with a list of hardware. And because I chose Ivory specifically, we're only presented with Ivory here right now. But if I were to select, say, a different version, I would be presented with a bigger list of core types. So before I go ahead and select my hardware, I quickly want to show some benchmarks that we ran with AVL Fire, which will give you an idea of what the best hardware type is to run with AVL Fire. So let me bring up this chart here. So I ran this case both on our Onyx core type, which is the latest Haswell processors, but uses 10 gigabyte Ethernet. And then I also ran it on the Ivory core type, which is the Sandy Bridge processor, but has InfiniBand interconnect. So as you can see from this chart, on a lower core count, Onyx is much faster than Ivory. However, as you scale up over more and more cores, we get much better scaling on Ivory. And you can actually see that we have super linear scaling here for Ivory. And this is because at lower core counts, we are very memory bandwidth bound. And the more you increase your core count, the more memory caches you have available, and so the quicker your memory access is. We can see that at 192 cores, the scaling for even Ivory starts to tail off. So for that reason, I chose to run this job on the Ivory core type. So let's go back to Rescale, and let me go ahead and select the Ivory core type here. And we can increase the core count to as many nodes, cores as we want. From the chart, it shows that we run as fast, the fastest on 128 cores. So I will run this job on 128 cores. I can also set my wall clock time here at the bottom. This will prevent me from accidentally kicking off a job that runs much too long. So in this case, I will set it to 2 hours. And then lastly, we can go ahead and review our setup. This will give you a short overview of what you've selected. So we selected AVL Fire version 2014.1 and running Ivory 128 cores. On the right side here, you can see a short overview of the price summary as well, including the hardware costs as well as the software costs for this job. So at this point, we're ready to submit the job, and so go ahead and submit it here. And this will bring us to the status page. And on the status page, you can see the status of the current job. And so whenever you initially kick off a job, you first go in the queued status, and then it takes several minutes to provision the cluster, to download all the files to the cluster, and to start running your job. So on this page, there's also 2 buttons here in the top right that I want to talk about real quick. The first one is the sharing button. This allows you to share your job with colleagues or with Rescale support or even with AVL support. So all you would have to do is select the support that you would want to share this job with, or you could share it with a colleague. For example, I could share this with Sarah. And then I could just share this. You can only, for security reasons, you can only share jobs within your company, so that you don't accidentally share it with your job with someone that you don't want to share it with. The second button here at the top is the clone button. And this button allows you to really easily clone the setup of your job, and this is very useful if you want to make small changes to your job. Say you want to just change a single parameter in your input file, or change the core type, or shorten the duration of your job, things like that. It's very useful to clone the setup of your job so you don't have to set up all the other things as well. So right now, our job is allocating resources. This usually takes about 1 to 2 minutes. And as you can see, our job has started running. The first thing it'll do is download our files from our persistent storage. And because they're encrypted while they're in persistent storage, we first have to decrypt the files. And so in the first few minutes, we'll decrypt the files. And then once the files are decrypted, the job will start running. So in the second box here below our Gantt chart at the top, there is a section, what we call the live tailing window, that which Sarah mentioned in her presentation. This allows us to look at the files that are currently on the cluster. This allows us to look at things like log files, images, and it even allows us to download the files if they're available. So at the moment, we're still decrypting and downloading the files. This will take a few minutes. You can always refresh the file listing here on the left, and that will update the file listing for you. You can also maximize the window, which can give you a better view of the file content. All right, so the files have been downloaded, and now we can go ahead and take a look at our log. See, we can actually also filter it by a name, so we can take a look at our log. Sometimes it takes a while to update. You can actually also take a look at the actual AVL fire log. And this will actually give you a look at what your job is currently doing. So our job is now iterating, and so you can see what the residuals are, and it will update in real time the status of the job. And lastly, what I want to show you is that you can also just download this log, so you don't have to necessarily look at it in your browser. All right, so this is the user experience for when your job is running. I'd like to now go to a job that has completed. And so I'll go to my jobs list, and I'll go to a job that I ran previously. And so once your job has finished running, your jobs will be, or your files will be encrypted and uploaded to your persistent data store. And they can be downloaded from the results page, which is shown here. We can either make a selection of files that you want to download. For example, we can download all our log files. and then we can perform some actions on these files. We can either download them, or we can delete them, or we can even create a new job using these files. And this is useful if we, for example, want to restart a job from restart files. Alternatively, we can download all the files using this blue button here at the top. And so that is the how you can download your results. And then the last thing I want to show you is what we call desktops, and this is remote desktops on Rescale, and this allows you to pre and post process your AVL fire jobs right in the cloud on Rescale. So I launched a desktop early this morning, and I have attached the AVL Fire software to it, and I have attached a few jobs to this desktop as well. We can download the RDP file from this window as well, and we can generate a password to log in. And you can generate a password as often as you want. But I've already logged into my desktop here, and I brought up the model that we're currently running. And so this is the mesh for this job. And so you can either pre or post process right on Rescale using desktops. And this concludes my demo.
Great, thank you, Moyanto. Let me share my screen once again. All right, and as a final note to the interface, I mentioned this earlier, but no matter which way you choose to execute these simulations, for our enterprise customers, we have an administration portal that adds another layer of security and control. This allows IT and management to track usage, set budgets, monitor and set software and hardware restrictions, and manage user permissions. So this is just an additional feature to the platform as well. So that concludes the webinar. We do have some time left for some questions. As I mentioned, if anyone who's joined later wants to ask any questions in the questions panel, they can. I'm going to answer the first couple that came in. And this first question is, how can a user access hardware in Europe specifically? As I mentioned, we have an EU platform. And to log into that platform, Moyanto is doing his demonstration with our general platform. For the EU platform, you just go to eu.rescale.com and sign up for an account. The interface will be the same. However, your data will reside and run in Europe. We similarly have a Japanese platform as well. The next question here is it possible to run a test or a trial of AVL Fire on Rescale? Yes, this is possible. You can reach out to Rescale. You can email info@rescale.com. You can email me directly as well at sarah@rescale.com. But there are trials available for you to, many customers want to try this out before committing to the transition to the cloud. So we're happy to work with you to set that up. It looks like that may be it on time for questions. Anything else we can address offline, and we'll send you emails directly. If there's follow-up questions, please feel free to email us, and we'll be distributing the recording of this webinar later. I want to thank David again for joining us, and I want to thank Moyanto both for your time. Thank you all for joining, and hope you have a great day.